All right, so like I said, we're moving on to the next unit already. This is going to go by really quick. Momentum is 3 sections and 3 sections only. So even though the test is beginning of May, which seems like it's not too long, the thing is you have a week and a half holiday in the middle of that. So typically momentum is done within 2 weeks from start to test. That's usually how long this takes because it's really quick. I have scheduled out till the end of the year already because we don't have that much time left. We've got the rest of this week, you've got next week, then you've got a week and a half off, and then 3 days, and then a 4-day week, and then we're basically already in June. So it's going to go by really, really quick. We've still got this unit, we've got circuits, and then we're going to have a waves project. So that's what we're going to do.
Waves project?
Yeah, waves.
Nice.
So any moving object has momentum. So it is going to depend on 2 things. It's going to depend on 1, velocity, and it's going to depend 2 on mass. So if an object has these 2 things, it has momentum. We can get into items like photons that have no mass, but yet there is some sort of a momentum to it. That's a different story. But for everything you'll get into, it depends on these 2 things. So here is your equation for momentum. This is not a P. This is a rho. This is a Greek letter, but most people write it down as a P. If you want to write this absolutely correctly, it should be kind of like a curved P like this. But if you put a P, I'll know what you mean. No, but if you go on and continue on in physics, you'll want to write it as a rho, because P is used up by many other things. So here's what each one of these things means. Rho is momentum, m is mass, v is velocity. You'll find in this unit the math and the algebra is really simple. There's nothing overly complicated with it. You've got this, you've got some addition, subtraction, that's about it. So not too bad.
Is this the only equation I'm going to use?
Nope, this is not the only equation. That's why I said there's going to be addition and subtraction. This has neither. So yes, obviously there's something more that's going to pop up. First section, yep. Okay. So momentum is also vector. So the v that is in the equation does have a magnitude and it has direction. We're not dealing with speeds, we're dealing with velocities. So it does matter if something is moving to the left or to the right. It makes a big difference. So in general, what we are going to use, and we'll continue this notation next year as well, traditionally, right and up are positive, down and left are negative. This is just traditionally how we've treated it. This is the same as your x and y axes. If you think about positive x, it's to the right, negative x is to the left, positive y is up, negative y is down. So we just continue on this tradition in physics, just because this is so common. The unit, kilogram meters per second, you can get that from your equation, since it's mass times velocity. Mass kilograms, velocity meters per second. Time will be in there somewhere once we get into seconds, but it's not in this direct equation. We can also write in this as Newton seconds, and I'll show you why in a little bit. It doesn't matter which unit you do. Newtons times seconds. Newton seconds. Because there's another equation that's, you might have guessed it, force times time. But just so you have that written down, that's the different units we can use. So let's try this out. Pretty straightforward thing to start off with. So let's calculate the momentum of a pumpkin. So momentum is mass times velocity. I give you the mass. I give you the velocity. So you can times these together. I'll use this one. Let's do kilogram meters per second for the first one. If you use Newton second for this, that's totally fine. I don't really care which unit you pick, as long as the unit is correct. We've got one person who's paying attention. Anyone else? 2, 3. I'm needing to deal with direction. This is. Well, let's try this. So, west is positive or negative? I'm going to include that as negative, so my velocity is negative. So when I times it, I'll get a negative number. Well, this I would not count as fully correct. Yeah. So to get this fully correct, I would expect you to get 31 kilogram meters per second west. You can just put W. So the negative indicates a direction, but negative could mean south, negative could mean west, negative could mean down, negative could mean to the left. So prove to me that you know exactly what direction it is because I state it here. If I did not tell you a direction, you cannot put a direction in the question. So only if I give you a direction in the question can you give me the direction. So if suppose, it wouldn't work in this case, but if suppose I didn't give you a direction and you got a number that's negative, just leave it as negative. But always check to make sure if there's any direction in there. Yeah?
Can I have the negative and the direction in it?
No. If you said negative west, that means east.
You have to cancel each other.
It's not that it cancels it, it just means negative means the opposite direction.
Negative and negative changes direction.
Yeah.
So if it's east and right, negative west, that's right.
Technically, it's just weird. That's like writing, instead of it being 40 meters per second, you're going to put it's negative 40 meters per second.
It's not.
It's not incorrect, but there's a more correct way to write it.
There is no direction, it's negative, we write it as negative.
Yeah. Yep. If there's no direction, just leave it as negative.
You missed me, right, mister?
So, yes, T, I missed you. So we've got a baseball mass of 0.14 kilograms. It's moving 35 meters per second. We want to, A, find the momentum of the baseball, and then B, we're going to find the velocity of a bowling ball if it has the same momentum.
Mister, when 8 doesn't tell us which direction.
You have this direction.
So if there's no direction, I just do it like normal. So I have mass.
Mister, Mike, the last one as Newton. What line?
Let's do Newton seconds. Why not? So here's the momentum of the baseball. It does not give us direction, so we don't put that in the question. I just leave it as this. So now we're told we want to find the velocity of a bowling ball. It has the same momentum. So we're going to use the exact same equation, except I know different variables. So I know 4.9 is the momentum. I have the mass at 7.6. Now I want velocity. Algebra. So do this. You will get 0.645 meters per second squared. Did I make a... Yeah. Yeah, because the mass is drastically different. So 0.645. So bowling ball has a huge mass compared to the baseball. So if you've got the same momentum, the bowling ball is going to move a lot slower. Momentum is a quantity of something that has mass and Velocity, the hardest part with momentum is giving it a direct definition. It's basically, I view it as how hard it is to change a object's speed or direction, or which would just be velocity. So think about this. If you've got a, let's see, what have we got? If you've got a truck that's coming at you at 5 meters per second, and if you have a giant styrofoam ball that's coming at you at 5 meters per second, which one's going to be easier to slow down? The ball. Why? Because it has less mass. I can talk about the same thing. If your younger brother's coming at you at 1 meters per second, or if they're coming at you at 10 meters per second, which one's going to be easier to slow down? The slower one. So if you have less speed or velocity, less momentum. It's easier to slow it down. If it has a bigger mass, it's harder to slow down because it has more mass.
It's weird when they say like a team has more like is gaining momentum. Like what do they?
If a team is gaining momentum, so if a team is gaining momentum, it's like
Gaining mass over
it's
the other team.
it's yes, you're getting fatter as the game goes on. No, it's basically saying if you're gaining momentum, it's hard to slow you down, or it's hard to hold you back.
Yes,
It's kind of dealing. It's more of a metaphor. It's not that you're actually physically gaining momentum. It's more like if someone's gaining momentum, it's hard to stop them.
yes, their mass becoming.
Because I always use that word like when I'm playing FIFA and I score 1-2 goals, I have my lead, like score more.
Yeah. So it's yeah. Okay. So moving on from that, there's something to remember here. So if we're dealing with a change in something is final minus initial. So if we talk about a change in temperature, final temperature minus initial temperature. If we're talking about a change in marks, we're talking about final minus initial. If we're talking about a change in momentum, final momentum minus initial momentum. So if I'm dealing here with a water balloon that's thrown against a wall, we want to know what's its change in momentum. So if I'm dealing with change in momentum, I'm going to have momentum final minus momentum initial. So I can calculate both of these. I know what momentum is, mvf minus mvi. Shh. We only need one teacher in the class, thank you. So I have all these. I know the masses, I have the velocities, so I can solve for this. Notice the final velocity here is 0. So I don't need to deal with this. That goes to 0. So I'm left with negative 0.5 is equal to the initial mass. Are we told direction in this case? No. So I'll just leave it as that. So we get negative 16 meters per second. Sorry, not meters per second because we're not dealing with kilogram. Meters per second. So notice, here's a negative. We're going to leave it in the answer. What does the negative in this case mean?
It's moving either left or down.
Left or down? It comes to a stop, but why does that mean it's negative? It's decelerating, which means your acceleration is negative. But why is my change in momentum negative?
Because you're not gaining momentum, you're losing momentum.
You're losing momentum, so you end up with less momentum than what you started with.
So if you end up with a negative, then the question doesn't make sense.
Yeah. So let's try the second part of this. So let's look at part B here. So now instead of a water balloon, we've got a bouncy ball. So now it's going to hit the wall at the same speed, but it's going to bounce back at 32 meters per second. So we want to know what is the change in momentum of this one, and how does that compare to the first one? So we're going to do the same thing. So change in momentum, this is going to be momentum final, minus momentum initial, MVF minus MVI, safe. Shh. You're talking all the way across the room while I'm trying to teach. So I have all these values. The problem is, let's try and figure this out. So the mass is the same. We've got 0.5. What is the final momentum? 32 minus the mass, and what's the initial speed? 32.
So it's gonna be 0.
Does that make sense?
Because when it goes, it comes back at the same speed. So it's
Yes,
doesn't really make a change.
but think about your momentum. Does momentum change if something's bouncing off?
Yes.
Yeah,
It should. Where's the mistake in this? Because I will see this many times over.
One of them is negative. The 0.5 on the right side is supposed to be negative.
One of these needs to be negative. Why? Does the mass change?
The direction.
My direction. So what's happening in this question? Ball's going this way. Ball's going this way. So even though they have the same speed, one of these needs to be positive or negative. So in this case, we're not told direction, so you don't know, is this going left or right, and is this going left and right? So I don't really care which one you put as negative in this case, but one of your velocities needs to be negative. Let's just put this one as negative. Same speed. Thrown at 32, bounces back at the same speed. Notice it didn't say same velocity, because that would be a lie. You can't bounce back and have the same velocity. So doing this, add these together. I just keep switching back between kilogram meters per second and Newton seconds just so you get the hang of it. But I don't really care what unit you pick for that.
So, what's the case when you use that as the kilograms?
It doesn't matter. I'm just saying, like I just said, I'm switching between them, it doesn't matter. You can pick whichever one you want. So how do these two change in momentum compare?
One is positive, one's negative.
Okay, what else?
One is gaining momentum and one is losing momentum.
Yeah, which is positive and negative. What about the magnitudes? Which one has a bigger magnitude of change in momentum?
The second one.
This one. This one's 32, this one's 16. Why does this one have a bigger change in momentum?
Because they don't have a higher velocity.
It's bouncing back. So if you bounce back, you have a bigger change in momentum. Any other questions with this? Yep. Okay. That's it. That's momentum. Which what?
How does it change compared to the higher momentum?
The second one is twice as large in magnitude.